Construction managers love Excel. We use it for absolutely everything, from estimating to quantity takeoffs to even contract management. But most of us are still manually typing out formulas and preparing the same reports every single week. We use it for the absolute basics, storing data in structured cells and performing the odd multiplication or average. Well, the goal of this video is to help you change that. I'm going to show you how to get the absolute most out of Microsoft Excel, not just basic formulas and an introduction, or we'll go through that for the absolute beginners here. We're going to show you how to set up project dashboards and charts, basic automations, how to integrate AI into your Excel workflow, and all the different applications to construction management. My name's Tim, and I've spent the last 10 years working for construction contractors where I've lived in Excel daily. Now I'm building an AI-powered construction estimating and contracts management software, which means I'm constantly working with construction data and the challenges teams face in using it. So the start of this tutorial is going to be super basic, so if you are familiar with Excel and the interface, skip ahead. But if you're completely new to Excel, we're going to start off with a simple overview of the software, what it is, and the absolute basics. I'll also put a link in the description of the video to some pre-built construction Excel templates that you can download for free. Okay, when you first open up Excel, this is what you're presented with. This isn't a blank workbook. This is a previously built template I've built for cost tracking and forecasting, but the example's the same. If you open a new workbook, you'll be presented with an empty sheet like this. The workbook is referred to as the overall file. The sheets are referred to as these tabs across the bottom. In addition to that, you have different ribbons across the top, which give you different tools you can access. So you have a home tab, which allows you to do certain things with fonts and formatting text. You have an insert tab that allows you to create charts. You have a draw tab, which allows you to draw on the sheet. You have a page layout tab, which allows you to play around with the orientation of the layout if you want to print it or export it. You have formula tabs, which help you to create formulas or select formulas. And you have a data tab, which allows you to import data and so on and so forth. You can actually adjust the ribbons you see. You can add extra ones or add other ones. So for example, this is a developer one for creating macros, but you might not need that. So you can adjust the tabs that you see. So once you're in a worksheet, how do you navigate through it? So to navigate to different worksheets within the workbook, really simple. You just click on the tabs below. Or if you want to add a new one, you click the plus button. To navigate within a worksheet, you can either scroll with your mouse or you can use these navigation bars at the bottom. The number of rows and columns you add is almost limitless. I'm not sure the exact number, but in my entire experience, I've never run into an issue with not being able to put enough data in a worksheet. Now, when navigating these workbooks, the other useful thing you can do is you can freeze panes, which pretty much means you can freeze the row at the top if you go into View, and you click freeze panes. So you can freeze the top row, you can freeze a column, or you can freeze a set of panes depending on where you highlight. And what this is really useful for is you have a whole lot of data down here, for example, you can scroll along and still maintain the heading so you know what column you're in. That makes navigating big data sets much easier. You can also zoom in and out. So if you control and scroll the mouse, you can zoom out on the workbook, or you can use this navigation bar at the bottom and zoom back in. If you have a workbook that you do want to print or export it, you can shift to a page break view. So for example, you'll see typical A4 page sizes on the workbook. So you can see that's page 1, page 2, page 3, page 4, so on. So the cells within the workbook are where all our data is stored. So different cells can have different format types. So if you right click on a cell and you go to the format cells option, you can see all the different data formats that your cell can have. You can have general, numbers, currencies, dates, time, percentage, so on and so forth. So for example, this number, the quantity is a 1, so it's a number, it's the correct format now, but I could change that to a percentage and it would show up as 100%. The format of the value in the cell is actually something to pay attention to, because a lot of the times you get errors, it'll be because you're comparing numbers with different formats, which can cause Excel errors. Within a cell, you can also change the font and the formatting on the home tab and the alignment of the text. So you can play around with all of these depending on how you want your workbook to look. Now, when we save an Excel workbook, there's two formats we can save it at. So we can save it as an XLS file, or there's actually a ton of formats, but the two main ones are XLX file or a CSV file. CSV file is a text representation of the workbook, which works with more different types of software, but you'll lose any formulas you've got saved. These would just be stored as text. Now we've got a basic overview of the main Excel interface, sheets, what everything means. Let's start going into the mechanics, spreadsheets, calculations, and formulas. So the first thing I want to talk about is the basic arithmetic formulas. So within Excel, you can do things like addition, subtraction, multiplication, division, basically any basic mathematical function you can think of. All you do is simply type the formula in the cell. For example, if I want to add these two numbers, 1500 plus 2300, all I type is either 15, I can type it directly in the cell, 1500 plus 2300, or like I did here, I can reference the cells with those values. I can do that for addition, subtraction, multiplication, division, and also exponential. So for example, 2 to the power of 3. Okay, so if I go through some more construction specific examples of this, say we've got a series of materials that we need for our construction estimate. We've got an item, a quantity, a unit cost, and a total. We can simply put in a formula, or we have the quantity times the unit cost gives us the total cost. And like that, we've calculated the materials we need for a specific project. Then we can take a row of values and add a sum function. So now I'm going to talk about the sum function, which is actually one of the most useful Excel formulas. So how the sum function works is you have a row of data. You can then type in there equals sum and enter that input range, and it'll calculate the total. So for example, equals sum C5 to C9. So you want to type it out manually, you go equals sum, and you can either type C5, you can either type the numbers in manually like this, or the other way you can do it is you can simply highlight the cells you want to use. So in practice, how would we use this? Say we've got a number of values that we've entered manually, costs for a project. We can then get the total cost by summing all of these values. The next very useful function is the average function. So instead of wanting the sum of a series of values, imagine you wanted to average them. The exact same way, you can type equals average, highlight that range of values, and it spits out the average. So you've got 5 days of data. You want to know the average production you're getting per day. Select that range of data and click average. You could also do this manually using the sum function. So for example, you want the average of this row of values, you can go equals sum, then you can go equals count, which counts the number of sets of data you have. And then because the average is the total divided by the count, you get the average like this. So I can go equals average and highlight the data, and I'll get the exact same answer. Now, because sum and average are such useful formulas, Excel will actually give you the values automatically. So if I highlight this set of data, you can see it's telling me the count is 5, so I have 5 data points. The sum is 635, and the average is 127. The next useful formula you should know is min and max. How min and max works is you have a range of data. You can select that range and type max, and it will tell you the highest valued data point in that data range, and min does the opposite to that. You take a range of data, you go min, and it'll take the lowest data value. The range is the difference between min and max. Practical application to this, the construction, is say you have a range of quotes from 3 bidders, you've got all their packages listed out, and you want to know the combination of the lowest bids between bidder A, B, and C. If you split up packages, you can just take the low bid, which would be the minimum of each range, and then get the sum of that. Count, I've already spoken about. Count is a very simple formula where you can highlight a range of data and it will tell you the number of data points within that range. Now, sum, average, min, max, count, they're all very common formulas that you should be aware of. Something I want to point out is that within these formulas, there's variants of every single formula. For example, you can have count A, which counts the number of cells in a range that are non-empty. Normal count, which just counts the number of numbers within that cell. Count blank, which would count the number of cells that are blank. So you can see all these different variants of the formulas. Count ifs, which will only count cells that meet a certain condition. So you'll find the same range of formulas and options for each of these different formulas. So you can get average if, average ifs, sum ifs. So all these different formulas will have variants that you can use depending on what specific data you want to look at. For example, if I want to go count ifs, the range, I want to know the number of RFIs that are open. I go count if and then put in there open, and it will tell me 4 RFIs are open. I change that to closed, change that from closed to open, that number will go out. So all these different formulas have variants within them that you can play with. The variant you see with all of them is the if variant. So if functions let you perform logical checks on data. So say for example, you have some quantitative data, which is the number of days since a certain RFI was submitted. So structural steel was submitted 5 days ago. The concrete mix design was submitted 12 days ago. The rebar shop drawings was submitted 3 days ago. You want to know if any of these RFI responses are overdue and the client has a 7-day turnaround time. So you can use an if condition to do that. The way if condition is used is you enter a formula with some sort of logical test. So for this example, I'm saying if the value of B5 is less than or equal to 7, so 7 days being the time the client has to respond, it is equal to on time. So it's still within that 7-day period. If it's greater than the 7-day period, it's overdue. So for example, here, if I change this 5 days to 9 days, that RFI is now overdue. So what I've done now here, which is very effective, is I've taken quantitative data, like the number of days since an RFI was submitted, and I've transformed it into qualitative data. So for example, another one, if we have a column of cost items and we have a budget and an actual, and we want a simple condition that if our actual cost is less than the budget, it's under budget. If it's over the budget, it's over budget. So our if condition is simply if the actual column is less than or equal to the budget column, then it's under budget. If it's greater than, it's over budget. So when we're talking about sum, average, min, max, if conditions, they're all about processing single sets of data. VLOOKUP is one of the most useful formulas you'll use when dealing with Excel data because it allows you to relate data sets. Say for example, we have a table of different material cost items. We've got concrete, reinforcement, formwork, framing, blah, blah, blah. Each of these has a unit and each of these has a unit cost. So we're putting together an estimate or a summary of our cost items. We want to link this material cost database to our estimate pricing sheet. So what we can do here is we can use a VLOOKUP function. So the way a VLOOKUP function is we search for a certain item, in this case, the material code, and then we look at a certain range of data to extract a certain value. So for this example, in this table, we're searching for this code, CON001. It's in this range of data, which is this table. We're looking for the fourth column value, so 1, 2, 3, 4, which is the unit cost, and we want it to return the exact value. That situation, we can search for this value. And when I change this value here, so I change the unit cost from 145 to 120, it'll change in our estimate sheet. Now that doesn't seem this useful because these are in the same workbook. Sorry, these are in the same worksheet. But if I look at a more complicated example of a construction estimate, I'll show you exactly how this works. So for example, here I've got a pricing workbook and I'm pricing the activity to supply and install a blind. What I need for this activity is I've got my material, the concrete, I've got some labor, concrete labor, and I've got plant, which is concrete tools. All I'm going to do is link the resource rate in my resource library. So this is the library of all the resources I need on a project. I'm linking this to my pricing sheet. So all I have to enter is the quantity, the resource rate to get the total cost. And when I update the price in my resource library, it's going to update across all of my pricing workbooks. So I can link basically a resource library to all my individual pricing sheets. Now, one of the big challenges with VLOOKUPs is the data has to be exactly correct. So say I have an issue in my pricing workbook and instead of typing B, I miss one digit. You can automatically see that there's an error in the formula, or for example, I have an additional space, it'll cause an error. So what happens is when you're using these sorts of formulas is you actually need your text to all perfectly line up between cells so the search function works, which is where we use text functions. So text functions allow you to break down, process, and append text. So say for example, I've got this item 03 conc 001. So some sort of activity code or workbook code. I can break this up into different text cells. Say I want to know all these different codes that only contain the text concrete and they've got 2 digits before and 3 digits after. I can take the middle 4 digits with the mid formula. If I only want to know the division they're in, I can take the left 2 digits. If I only want to know the end number, I can take the right 3 digits. So text functions allow you to break down specific sets of data. You can also fix text up. You can put everything in lowercase. You can put everything in uppercase. You can put everything in proper casing, so the first letter has a case, or you can trim blank space from a text. For example, see this spaces at the start. You can trim that to get the cleaner text. You can also combine different sets of text. So say, for example, you have an RFI number, a division, and a topic. You can then combine these together to get some sort of combined label. Then finally, if you simply want to know the length of different texts, you can use the length formula or the position formula if you're looking for where a certain character is. Now, as we know, Excel lets us use lots of different formats of numbers, and that's why, particularly with construction and around construction scheduling, invoice tracking, these sorts of things, it's very useful to be able to work with date functions. So a date format is a different type of data within an Excel workbook. And there's different formulas we can use to process the data in a way we want it for. So something I use very frequently for construction scheduling, and it's very useful, is this idea of a calendar day versus a work day. So most construction projects, we don't work on weekends. We might work Saturdays, but typically we don't work weekends. So for example, if we know a task is going to take us 15 days, we don't want to know the number of calendar days, which would be the difference between these two numbers. We want to know the number of network days, which are Monday to Friday work days. Now, you could adjust this. You could have your own network function and include holidays in there. But very basically, you can then look between the 26th of October and the 10th of December. There is 14 calendar days, but only 10 work days. So this work days is much more useful when you're calculating true project durations. We can rearrange this formula. Say, for example, we have 15 working days for our shop drawings to be approved, and we want to know what date our shop drawings are going to be approved. We can simply add 15 work days to the start date to calculate the completion date based on the number of working days. You can also group different sets of activities using date formulas. So you can take a date, and again, this is the text representation of a date. So when you're looking at a date number, you can go format cells, date, and you can show it as a date versus as a number. And for each of these dates, you can extract the year, the month, the day, or the days until the end of the year. So there's all different formulas you can do to process time information. Now, the final set of functions I'll talk about, which are very, very useful, are if-error functions. Why are these useful? Because if you're dealing with big sets of data and you have formulas or calculations where you might have errors in them, you might be dividing by zero if something's zero, what will happen is you'll start to get errors like division by zero or error, which will break. For example, if you have a sum function here, it'll cause the whole sum function to return an error. If error is an incredibly useful function where you're dealing with data like this, is you can simply put an if error at the start of the function, and instead of returning an error, it'll either return some sort of text or some sort of zero to make it much easier to process. Now, that was a very, very brief overview of all the different formulas you can use, but it is probably 0.1% of all the formulas out there for Excel. The thing that I found with Excel is there are so many existing formulas. You can use the formula bar to better search for and understand what specific formula you want within Excel. Or what I've been doing recently, which I find 100 times easier, is simply describe the formula you want in something like Claude or ChatGPT. Tell it how you're trying to transform the data, what you're trying to do. And almost always it will give you the formula you want. So I don't really use this formula function much. I just tend to describe what I want in ChatGPT or Claude, and it'll find the formula for me. And often there is already an Excel formula out there that can do it. Okay, so we've spoken about formulas and functions and all the different calculations and things you can do with data sets. Now I'm going to move on to talking about data organization and management, because as your workbooks get more complicated, more sophisticated, this is going to become an increasingly important thing to be able to do. So let me explain what the problem with regular ranges and formulas is, and this is going to be a problem that progressively compounds as your workbooks get more and more complicated. So say, for example, we're doing a takeoff of the materials we need for a concrete slab. We've got a concrete foundation, reinforcement, formwork, and the next thing we want to know is the number of penetrations. So we do this, we add a line to this formula, and we go penetrations. We've got 4 each. The unit cost is $500, and boom, blank, nothing. What has happened here is when we've added a line, the formula hasn't copied down. So we would have to do that manually. Every new line you start leaves a blank in your formula, which again is fine if you're doing a small worksheet and you can quickly fix it and drag these things down. It's not the end of the world, but as if you start to deal with more and more complicated sets of data, you want to be structuring and organizing your data in the right way to prevent stuff like this happening. Because at the end of the day, you'll forget once to drag a formula down and you'll have some sort of costly error in your estimate, which you don't want. So Excel's solution to this problem is to convert your data into tables. This is an example of an Excel table, and basically it solves this problem of when you add a new row, formulas will copy down. So for example, the quantity and the cost column have been referenced here, and as soon as I add a new line, they're already referenced. So I go penetrations, quantity, 5, each, 400, the formula is already copied down. Again, this is a silly example. It's little, but as your workbooks get more complicated, it'll make things much easier for you. Top of that, in addition to your formulas autofilling, you also get structured references. You're not having to deal with cell numbers. You're getting quantity times unit cost. Your formula, your data will automatically filter. So say, for example, you want to know just reinforcement or just penetrations and filter it. You can also sort your data. So say, for example, you want your data ordered by the highest unit cost or the highest total cost. You can sort all of your values like this. And it's also easier to externally reference the table. So to create a table, all we do is we go highlight our data, we go insert table like that, and it converts it into a table and we get all this added functionality. Now, the next Excel hack I'll give you with managing your data is data validation. This is particularly important when we're talking about qualitative data. So say, for example, we have a whole set of activities and we want to categorize these activities by trade. If we start typing in one trade, civil, but then in another situation, we call it civil team or civil contractor, we start to end up with all these different tags for the same data, which is going to be if we want to sum all the activities or count all the activities allocated to civil team. And we've got civil team, maybe we have a spelling mistake somewhere and we forget the I. All of Excel sees all of these as different data points. That's why when we're dealing with qualitative data, so we want to add a descriptive tag to something, we should use data validation. So data validation is where we add to a cell a list of options we can choose. So here, when we're categorizing these things by trade, we can only put a specific value. And whenever we put plumbing, it's going to be the exact same. So if we count the number of, so if we go count if this range plumbing is spelled the exact same way. So we can't type in there plumbing. It'll correct it. So that this fixes a problem with spelling mistakes and categorizing qualitative data. Now, sorting and filtering data, again, is very useful when you have big sets of data. So for example, say we have this RFI register, I've converted it to a table and we have a status column. We want to know the status of all our RFIs that are open. We can simply go to the status column and filter based on the tag open, and we can instantly say, these are the set of RFIs that are open. We can also have multiple filters on at once. So say, for example, we only want to know the high value RFIs that are high priority RFIs that are open. We can have double filters, which is priority and status. To clear the filters, we can either manually do this, so add in back all this data, or we can go to data tab and click clear filters. To set new filters on a table, you convert it to a table, or you can create filters by highlighting cells. Pivot tables are another type of data where we have a large set of data and we want to know sums across activities or items. So say, for example, we've got this table and we want to know the sum of all the total cost of all the labor. We can highlight this entire table, then go insert pivot table. We can either go recommended pivot table or we can create our own pivot table. So we can do this by clicking recommended pivot tables or creating our own one. And I want to know the sum of total cost by grouping. I go down to sum of total cost by cost code, click this, click OK. And there we go. I've got a summary of cost by the different cost codes. You could do this Based on looking at this data, you could do this by project, trade, whatever. But pivot tables are very easy ways of summing and categorizing your data like this. Pivot tables are super flexible. You can show whatever you want in the rows and columns, depending on what you want to do with your data and what numbers you need to know. Now, what I've spoken about so far are the basic building blocks that you can use to put together some very fancy and complicated stuff. Because at the end of the day, construction is very, very simple. It doesn't get much harder than multiplication and division, but it involves dealing with lots and lots of data. So using these simple building blocks of the formulas and the data management we've spoken about, now I'm going to go through and show you some fancy things you can build or show, and all these templates I've got for free in the video description if you want to download them and start with the pre-built templates. This here is an estimating workbook, which is what I use to price my projects, and it's a structure that I absolutely love because it works for me and the way I think about estimate. How it works is you have a resource library. So these are the rates you're going to use to build up all your costs. This is just a very simple table that contains different resources with a type, a unit, and a final rate. This is what we're going to build our price on. So at the end of the day, estimating is combining a ton of different resources to build a price for activity. We've got a work breakdown structure, which is our breakdown of the project we're trying to price. So these are all the different activities we want to price. Now, I like to have my project broken down into direct costs and indirect costs. Again, I'm not 100% sure if everyone uses this terminology, but a direct cost I like to think as the pricing schedule the client has given us, and this is how we want our quote broken down. Each direct cost item has a quantity, a rate, a unit of measure, and a total. An indirect cost item are items we want to include in our price that we don't want our client to see, but they're going to be spread across our direct costs. For example, risk might be one of these. You might have project management if it's not broken out in your pricing schedule, or mobilization and things like that. Then you apply a markup percentage to it. This spreadsheet is super, super simple, but for each of our direct cost items, we have a line item which corresponds to a worksheet. So this is a pricing worksheet, and all we do to build up our price is we select a resource from the drop-down list and this uses a VLOOKUP. It'll search the rate for the material. So say I want to add 100 meters squared of formwork supply to this, then my rate is $50. If I update this rate in the resource list, it will change that $50 rate. And as I go into my work breakdown structure, this total price, so the sum of all these items, $7,000, is the cost shown in my main pricing schedule. These are the cost items. Applied to the cost is the sum of my indirects, which are spread over the direct cost, plus my profit margin. So while this spreadsheet looks fancy, all it's really using is that same VLOOKUP structure, multiplication, some sums, some very, very simple formulas. The next spreadsheet I want to show you is a very simple cost tracking sheet. What a cost tracking sheet is it allows you to track your budget and how you're spending money throughout the project. Again, it's going to be made with some very simple formulas, VLOOKUPs, and sum functions. It's broken down into two different tabs that you need to use. Your cost code tab, which is a breakdown of your total project budget you have to complete the project, broken down into separate cost codes. So a cost code is simply a bucket of money you have to do a task. So for this project example, I've got project management and supervision as a cost code, site setup and amenities, footings, formwork, blah, 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 whatever it is. Then against each of these cost codes, I've got a budget amount. So this would come from our estimate when we initially priced the project. So for example, for project management, I've got a budget quantity, which is 20 weeks at a rate of $8,000 per week, which is $160,000, which is my budget to do that task. In addition to that, I also can adjust my budget through the execution of the project. So for example, we put in an extension of time claim to our client. They give us an extra 4 weeks at a rate of $10,000 per week. I get a variation amount of $40,000. My new revised budget is simply my initial budget plus my variation amount. Then we tag each of these buckets of money as cost code, and we give it a numerical code. Then to track our cost to date, all we do throughout the execution of the project is every time we pay a bill, receive an invoice, pay employee wages, we allocate those costs to a cost code. So for example, this is preliminary costs in week 1, our project management and supervision. was $6,200, and we allocate this to cost code 1001. So if I go back to the cost code sheet, you can see that our expenditure to date, which is coming from the cost tab, is $6,200. So against control account 1001, we spent $6,200. So we know what our original budget is, what we spent to date once we enter and track all our invoices in here. To get our forecast, what we think it will cost to complete the project, we need to put in our quantity to complete and our rate to complete. So the rate we're actually spending money might be different to our budget rate, and the quantity we think we have left might be different to our quantity, our initial budget quantity. Therefore, our rate to complete times our quantity to complete gives us our cost to complete. Our forecast is what we keep updated throughout the execution of the project, so we have a very good feeling of whether we're going to make money or lose money. Then our cost at completion, so what we're going to have spent by the time we finish the work, is simply the sum of our cost to date plus our cost to complete, which for this budget is $297,150. Our initial budget, or our revised amount once we got that variation, is only $200,000. Therefore, this number is shown in big fat red, and it shows that we're going to overblow the budget by $97,000. Again, very simple calculations, very simple formulas, but we instantly know that this project, using, again, a subtotal formula, we're going to be losing about 200 grand. We're going to be going over our initial budget of $1.6 million by about $270,000. Now, the rest of these templates, I'm going to more or less fly through, but again, they're all very simple. If you spend 10 minutes looking at them, you follow through the formulas and see how you work, you're going to be able to work them out very quickly. But this one is an example of a cash flow forecast. What this lets me do is it lets me put in my bank balance, my payments, my revenue from my clients, my anticipated payments, and when I'm going to be incurring these bills, maps these together, and it helps me map out my cash flow. So based on different payment terms, bank guarantees, retention, pre-purchasing materials, or delayed payments, I can forecast out my cash balance so I need, because I can see how much cash I need to run my projects. This is a bit of a fancier spreadsheet, which is a very simple project dashboard and project reporting function. You can see it shows an S-curve, which is planned expenditure and cumulative expenditure over time. It shows my cost code variances against each of my trades, and it shows my weekly resource hours. Again, this is just using simple graphs to display this, and all the data is linked behind here. You can see different percentages, which is what this dashboard is referring to. Cost data, which is looking at the variance across different cost codes, which is shown on this dashboard. And then weekly resource data. So looking at different dates, the number of hours, equipment, labor, whatever I'm using, I'm just showing it as a simple histogram. The next spreadsheet is a project variation register where you can track, price, and communicate all of your variations to your client. It works, it has a cover page, which is a summary of all your variations with a title, status, date of notification, date it's been approved, EOT, total. And then these totals are linked to the different variation tabs. So each of these variation tabs is a simple form you can fill out. You can then print and export it to Excel as a way of sending it to your client. And you can put a breakdown of your pricing in it. Again, it's a good way of tracking your variations and also communicating these to your client. Again, I could go through hundreds of templates and talk about lots of different things, but at the end of the day, your ability to make things like these or use things like these comes down to how you experiment and play with Excel, and also have a really good understanding of what you're trying to do. Because I guess the key point I'm trying to make here is your ability to use Excel is not necessarily going to be limited by the skills of using Excel. It's how you can apply it to solving construction problems. Okay, the final thing I want to talk about, and I briefly spoke about it when I was showing this project dashboard before, is how to actually turn your data into charts. So say I have all of this schedule data and I want to transform it into an S-curve like this. The way to create a chart in Excel is you highlight the data you want to plot. So I want to show my planned and actual expenditure. I click on the Insert tab, and then I look at the different charts I want to choose. I can either select a chart that I know, a certain type of chart that I know I want to create, or I can simply click recommended charts. So recommended charts will give you a whole lot of different options. these will give you restricted options. So if you say you want to do a line chart, or if you want to do a bar chart, it really depends what you're trying to do with the data. So for me, for this example, I want to insert a line chart. I look at my different options. I want to do an S-curve. So I select simple line graph. I plot it here, and you can see it's plotted our planned expenditure and cumulative expenditure, and it's done this across weeks. We can then fix up this chart. We can name this project S-curve. We can fix up the range of percentages, because as we know, like over 100% doesn't really make sense. So we might want to restrict the access on that. So I go to my access options. I look at my vertical value access, and I change the maximum to 100%. And then now we can see that the only range we can see is 0 to 100%. I've got a legend. I could remove the legend. There's a whole lot of things to do. Just play around with it. Creating charts in Excel is incredibly easy. So charts, formulas, functions, it's all very simple. I recommend just play around with it, see what you can do. It's an incredibly powerful software. Again, I can keep going on explaining different formulas, but I just don't think it's that useful. Much better off trying to play with it. Play with some of the templates that I've got in the video description. You'll see different ways you can do things, and Excel is very much down to your creativity and how well you understand the construction problem you're trying to solve with it. So the next thing I want to talk about is I wanted to do a section on Microsoft Copilot and using Excel AI. So I'm not sure if you've seen this Copilot icon in your Excel interface, but the idea is that you can prompt Excel the same way that you can prompt ChatGPT. So the idea is you can type in a prompt like, how many weeks of scheduled data is there? Now, I started playing around with this feature, and I wanted to do something much bigger on Microsoft Copilot, but I found it incredibly limited. So it's actually answered correctly there, but almost every other time I prompted it and asked it to do things, it has been absolutely terrible. So originally I wanted to talk about Microsoft Copilot, but instead I'm going to show you my favorite AI that I use, Claude, and how you can integrate it with Microsoft Excel. So I was a little bit taken aback there by how well Copilot actually worked, but every other time I've tested it, it has been absolutely useless. It hasn't recognized the data. It hasn't really given me anything meaningful. So I'm not going to talk about Microsoft Copilot, but Claude I find to be incredibly good at Excel. There's a couple of different ways you can use Claude with Excel. You can, like I was suggesting before, you can ask it for certain types of formulas. So say, for example, you describe your problem to Claude and say, I have a range of data in Excel and I want to take the average of it. How can I do this? Data is in range A1 to A10. You can type that into Claude, and Claude will give you a formula that you can use in Excel. So I find that much easier than trying to use this formula feature in Excel to look for formulas. All you can do is just take this formula, copy it into Excel, and you've got the formula you want. The second way that you can use AI with Microsoft Excel is you can copy data like this directly into AI and get it to perform some sort of analysis for you. So say I copy in this range of data, and I want to ask Claude, for this range of data, what is the average budget amount of each package? So this is a very simple example, but it's told me that looking at your data, the average budget amount of each trade package is $196,875. And if I check that against Excel, we see the average is $196,875. So you can use it in a similar way to you manually processing the data. Claude, I find incredibly good at maths and structured data calculations, but you can copy in the data and ask it similar questions. Now, the third way you can use AI, which this is probably the most powerful feature, is Claude, and ChatGPT does this as well now, but you can actually create Excel templates with AI. So if I prompt Claude, create a cost tracking spreadsheet I can use for my project that I can export to Microsoft Excel. I want a summary page with each of my budgets and another page where I can enter invoices and allocate these to cost codes. Create an output, I can export to Excel. So if I give Claude a prompt like that, it'll actually create a template for me. And looking at the output that Claude has produced, you can see that there's a budget summary with budget amount, actual amount, committed, forecast, so on. And then a section we can enter our invoices. You might not like it, you can prompt Claude again to say, change this, change that, whatever you want to do. But it's created a pretty good starting template. You can then download that and open that in Excel directly, and you have an Excel template that you can start using. So I hope that helps. Again, I think there's only so much you can teach about using these softwares. You just have to start experimenting and playing with them and trying to build things. Hopefully the templates help a little bit with getting you started. But again, you really just need to understand, what are you trying to do with Excel? What are the inputs? What are the outputs? And what are the capabilities of Excel? And how can you build something that saves you time and effort? If you want to know more, particularly about that construction estimating spreadsheet, then I'll put a link in the video description to the spreadsheet, and then also watch this video next where I'll go into more detail on how you use it.